A shark the size of a small bus washes up on a beach in South Africa. It weighs over a ton. Its jaw could snap a seal in half in one bite. And yet something has torn a hole in its side, reached in, and pulled out a single organ with the precision of a surgeon. Nothing else is touched. No frenzy. No chaos. Just one clean wound and one missing liver. 4 years, nobody could explain it. Now they can. And the answer is more unsettling than anyone expected, because the thing hunting the ocean's most feared predator isn't a disease, isn't a net, and isn't a human being. It's another animal. One that figured out how to kill a creature that has had almost no natural enemies for 16 million years. For most of modern history, the coastline near Cape Town, South Africa, was considered the single best place on Earth to see a great white shark in the wild. The waters of False Bay were famous for it. Tourists flew in from other continents just to sit in a cage and watch these animals glide past. Documentary crews built entire careers filming the sharks they're launching themselves out of the water to ambush seals near Seal Island. For decades, the population looked stable. It looked permanent. Nobody who worked on those boats imagined a day when the sharks simply wouldn't show up anymore. Then, starting around 2015, they stopped showing up. At first it was subtle. Fewer sightings here and there. Boat operators assumed it was a slow season. But the slow season didn't end. Sightings kept dropping, year after year, until by around 2018 and 2019, the sharks that had defined this stretch of coastline for generations had all but vanished. Individual sharks that researchers had tracked for years by their fin shapes simply stopped appearing on any camera, any tag, any boat log. An entire population that tourists and scientists alike had assumed would always be there had thinned out to almost nothing in a remarkably short window of time. Naturally, people wanted an explanation, and theories came fast. Some blamed commercial fishing for wiping out the sharks' food supply. Some pointed to pollution creeping into the food chain. Others assumed shifting ocean temperatures were pushing the sharks toward cooler water. Every explanation had defenders. None of them had proof. And while researchers argued over spreadsheets and satellite tags, the real answer was already washing up on the sand. Dead great white sharks began appearing on beaches near Gansbaai and other hotspots along the coast. These weren't storm-battered corpses or fishing bycatch. They were largely intact, several meters long, apex predators in their prime, with one bizarre and consistent injury, a precise incision carved into the body between the pectoral fins, and the liver missing entirely. In some cases, the heart was gone too. Everything else, the muscle, the fins, the jaw full of teeth, was left completely untouched. Whatever did this wasn't feeding out of hunger in the traditional sense. It was extracting something specific, and it was doing so with a level of control that looked less like an attack and more like a dissection. That detail is what eventually cracked the case open, because sharks are not supposed to have a predator capable of that kind of precision. The great white shark, scientifically known as Carcharodon carcharias, has existed in something close to its current form for roughly 16 million years. It has survived ice ages, shifting coastlines, and the extinction of countless other marine species. It can generate thousands of pounds of bite force. It can sense the electrical pulse of a heartbeat buried under sand. Its entire body plan is built around being the one doing the hunting, not the one being hunted. For most of scientific history, the working assumption was simple: nothing eats a full-grown great white shark. It sits at the top. Full stop. The bodies on the beach broke that assumption completely, and eventually, researchers traced the killer to two very specific animals. Off the coast of South Africa, marine biologists had been tracking a pair of killer whales for years. What made them easy to identify from a distance was an unusual physical trait: both had dorsal fins that flopped over rather than standing straight up, a trait rarely seen in wild orca populations. Researchers gave them nicknames based on that trait: port and starboard, after the way each fin leaned to one side. At first they were just two more animals in the catalogue. Then their carcasses started matching up. Orcas killing sharks isn't itself unheard of. Killer whales are famously flexible predators, and different populations around the world specialize in wildly different prey. Some hunt seals almost exclusively, some hunt fish, some target other whales. That specialization tends to be cultural, passed down from one generation to the next rather than hardwired by instinct. What made port and starboard remarkable is what they chose to specialize in. Bite marks recovered from the shark carcasses matched orca dentition. Necropsies lined up with a hunting method nobody had documented in this kind of consistent, repeated detail before. These two animals had built a specialized technique around killing great white sharks specifically for their livers. Piecing together exactly how they do it took years of patchy evidence, carcasses, drone footage, and a handful of extraordinarily lucky eyewitness accounts from boats. But the picture that emerged is remarkably consistent. A killer whale approaches from below and behind the shark, exploiting the one angle where a shark's sensory systems are least effective. Rather than going for an immediate kill, the orca uses its own weight and speed to ram or disorient the shark, targeting the area near its pectoral fins. This doesn't kill the shark outright. It stuns it, and more importantly, it sets up the next move. Sharks have an odd biological quirk that port and starboard appear to have learned to exploit ruthlessly. If you flip a shark upside down, it can enter a trance-like state known as tonic immobility. In this state, the animal goes essentially limp and stops resisting. Researchers believe the orcas use this to their advantage, flipping a disoriented shark so it stops struggling almost entirely. From there, with the shark rendered harmless, the orca goes to work on the liver specifically, biting through the underside near the pectoral fins and removing the organ with startling precision, sometimes taking the heart as well, and leaving the rest of the body behind for scavengers. Why the liver? Because in a great white shark, the liver isn't a minor organ. It can make up a huge portion of the animal's total body weight, and it's absolutely packed with a fat compound called squalene, which the shark uses for buoyancy and energy storage. For an orca, which needs enormous amounts of calories to sustain its size and its brain, a shark's liver is essentially a jackpot, a single, massive, calorie-dense meal that can be extracted without wrestling the shark's tougher, less useful body parts. It's efficient. It's cold. And it works. The consequences of this hunting style went far beyond the handful of dead sharks that actually washed ashore. Researchers say the real toll isn't measured in bodies, it's measured in fear. Satellite tagging data from sharks in the region showed a dramatic and immediate shift in behavior whenever port and starboard entered an area. Sharks that had held the same territory for years would abandon it almost overnight. And they wouldn't come back quickly either. In some documented cases, a single encounter, or even just detecting the orca's presence through the water, was enough to keep sharks away from a location for weeks, or even months at a time. That single detail rewrites how scientists think about the disappearance from False Bay. It was never really about 8 or 9 dead sharks. A population of that size, with an ocean that large to swim in, could easily absorb losses like that. What it couldn't absorb was fear. Every time port and starboard showed up, the entire local population of great whites appears to have gotten the message and left, sometimes for good. Multiply that pattern across years, and you get a population that essentially chose to relocate rather than risk staying. The ripple effects were immediate and visible. With the great white sharks gone, the seal colony at Seal Island, the same seals the sharks had spent decades hunting, lost their main natural check. Reports from the area describe seal numbers climbing without that predation pressure keeping them in balance. Fishing communities that depend on the health of that ecosystem started noticing changes in what they were pulling out of the water. The cage diving industry, once a thriving local business built entirely around guaranteed shark sightings, saw trip after trip come back empty. Two individual animals had managed to do something that decades of fishing pressure, pollution, and coastal development never fully achieved. They entered one of the most iconic shark habitats on the planet, almost entirely through reputation alone. And this isn't only a South African story. As researchers dug deeper, they found echoes of the same pattern elsewhere. Off the coast of California, near the Farallon Islands, great white sharks have also been documented clearing out of an area for extended stretches whenever orcas move through. Similar shark avoidance behavior tied to orca presence has been reported in other parts of the world too. It suggests this isn't some one-off local event, but a broader pattern that may be showing up wherever orcas and great whites share the same water. Which raises the obvious question, why now? Orcas and great white sharks have shared oceans for millions of years without this kind of documented, specialized predation showing up before. Some researchers think the explanation has less to do with the sharks and more to do with what's happening to orca populations worldwide. Killer whales everywhere are dealing with the fallout of human activity, pollution accumulating in their bodies, shipping noise disrupting the way they communicate and hunt, and in many regions, a shrinking supply of their traditional prey due to overfishing. Some orca populations are struggling to find enough food using the old methods. The theory is that animals like port and starboard may represent exactly the kind of adaptation that happens when a smart, social species runs into scarcity. They don't just keep doing what used to work, they experiment, and if something new works better, they keep doing it and teach it to others. That's the part that should genuinely give people pause, because orca culture doesn't stay contained to two individuals. Killer whale populations are known for passing down hunting techniques socially, the same way distinct pods pass down dialects or migration routes. If a technique is effective for extracting massive amounts of calories with minimal risk starts spreading through other pods, it isn't unreasonable to think other shark species could eventually be affected the same way, wherever their ranges overlap with orcas. And that matters more than it might seem at first, because great white sharks aren't just a spectacle for tourists. They are a load-bearing part of their ecosystem. By hunting seals and sea lions, they help control those populations directly. By preferentially targeting weak, sick, or injured animals, they also help keep prey populations healthier overall. Their mere presence changes the behavior of everything below them on the food chain, shaping where animals choose to feed, rest, and breed, simply because they might be watching. Pull the great whites out of that equation, even temporarily, and the rest of the system starts to shift in ways that are hard to predict and even harder to reverse. What happened in False Bay, the seal population growing unchecked, the fishing patterns changing, the entire local food web quietly rearranging itself, may only be the opening chapter of a much larger story. There's something almost humbling in how this all unfolded. 16 million years of evolution built the great white shark into arguably the most efficient hunting machine in the ocean. Every part of it, the electrical sense organs, the muscle structure, the row after row of replaceable teeth, is optimized for attacking, not for defending itself against something smarter. Sharks have no evolved instinct for fleeing a predator from above, because for almost their entire evolutionary history, nothing up there was a threat. Whatever fear response we are now seeing in these sharks isn't instinct. It's learned, and it's being learned the hard way, from encounters some of them don't survive. It's important to be clear about what this is, and what it isn't. Port and starboard aren't doing anything unnatural. They are not an invasive species, and there's nothing malicious about what they are doing in any meaningful sense. This is simply what apex predators do when they find a vulnerability to exploit. What makes it remarkable is the sophistication of the technique, the apparent intelligence behind it, and the speed at which it seems to be reshaping an entire coastal ecosystem. Researchers studying the pair have been careful to point out that this is a natural predator-prey relationship playing out in real time, just one that happens to be far more dramatic, and far more visible, than most. It's also worth saying plainly, great white sharks are not going extinct because of two orcas. The species is spread across oceans worldwide, and it's proven remarkably resilient over an extraordinarily long stretch of geological time. What's changed isn't the survival of the species as a whole, it's the balance of power in specific places, and the shark's relationship with fear itself. For the first time in recorded history, marine biologists have documented, in detail, exactly what happens when the ocean's most feared hunter meets something it has no evolutionary answer for. So the next time someone tells you great white sharks have no natural predators, you can tell them the truth: they used to be right. Off the coast of South Africa, and possibly in other oceans too, 2 killer whales rewrote that rule, one liver at a time. The bodies that washed up on those beaches weren't a mystery for long. They were a message. And every great white shark in the region seems to have understood it perfectly.